So one thing that you need to understand is that here, let's say they're saying this is A, B, C, D, E, F. And then one thing that you need to always remember, since they're now telling you this is A, B, C, D, E, and F, you're gonna have this on triangle ABC, you're gonna have this angle right here, as well as on triangle DEF, you're gonna have that angle right there. And then those two angles actually they are equal. And then one thing that you need to understand, they will say the length of BC is equal to the length of FE. So one thing that you need to understand, under Euclidean geometry, this is what we call the corollaries. So the thing that has to do with corollaries, the way they work, this one on this circle, triangle ABC and triangle DEF, you now understand that BC represents the chord as well as FE represents the chord, right?
Yes.
So this is a corollary or a theorem that says that equal chord subtend equal angle at the circumference. So here you need to always know how equal chords, equal chords, comma, subtend equal angles at the circumference. So that's one thing that you need to actually know. Okay, equal chords subtend equal angle at the what? At the circumference. So when I'm saying equal chord subtend equal angle at the circumference, this is what basically I mean. Equal chord subtend equal angle at the circumference. I'm trying to say BC. I'm trying to say if the length of BC it's equals to the length of FE, comma, what will happen? Then angle A is equals to angle D. So remember that Euclidean geometry says that each and every statement should be accompanied by the reason. So here actually we must have a reason. And that reason will be this one. You just write it there. Or even if you wrote it like that, it won't affect you. So if BC always is equals to FE, then angle A is equals to angle D. Reason key equal cos subtend equal angle at the circumference, or equal cos subtend equal angle at the circle. And then with regards to this one, the second one, this one, it's also part of corollaries. So this one, you'll get it like this. And then this one. So this one, you'll get it like this. And then still, that is angle A, B, C, D. And then let's say that is angle O. So with regards to this one, what's going to happen? This chord is equals to that chord. And then this automatically means to say this angle right here will be equals to that angle right there. So this one equal chords subtend equal angle at the center of the circle. So it means to say if AD in this case it's equals to BC, comma, then what will happen? Then it means to say angle AOD, angle AOD, angle AOD is going to be equals to angle VOC. So this one equal cos subtend equal angle at the center of the circle. But remember, each and every statement should be accompanied by the reason. So here we must have a reason. So that reason is the one that I'm gonna write here. That is the statement that says equal cos subtend equal angle at the center of the circle. Equal cos subtend equal angles at the center of the circle. So that's one statement that is very important. So the this statement, I'm just gonna write them here, but when you must write them there where I just wrote a reason. And then lastly, am I done? Okay, yeah. And then I think that the other one, these ones basically you know them based on revision purposes. I think this one they don't need me to just elaborate more because they're straightforward, whereby whenever you have I need to move on this thing. Oh wait. Okay. Let me do like this. Yeah. So these ones they don't need me to explain more. I think this ones you know you actually know them. This one you have learned more about Zohana. If they're gonna say that is A, B, C, D, then that is gonna be D1 as well as angle D2. This one you know them based on what I've just told you. You now know her angle D2. We all know her angle D2 is going to be equals to angle A. And get so
Yes.
so this one reason get the exterior
Angle of a cyclic quad.
is exterior angle of cyclic
Quad.
cyclic quad is equals to the opposite interior angle and get
Yeah.
interior angle and get
Yeah.
yeah. So this basically means to say this angle D2 is equals to angle A always. And then not forgetting what happy just that I don't want to draw another diagram. You can also conclude and say angle A plus D1 again. You can also conclude your angle A plus angle D1 is going to plus angle D1. D1 is going to give you what 180 degrees. So reason the opposite interior angles of a cyclic quad. Opposite interior angles of cyclic quad supplementary. So in mass, remember supplementary angles, these are angles that add up to 180 degrees. So it basically means to say if I'm gonna add angle A plus D1, I must still get 180. Okay. Are you with me?
Yes.
Yeah. And then apart from that one, this one I think you also know it. The angle between a tangent and a chord is close to the angle in the alternate segment. So if we're gonna say this is tangent A, BC, and then here we're having D and E. And then here, let's say that is gonna be B1, B2. Or rather, let me say B1, B2, B3. So ABC is a tangent because a tangent is a straight line that touches the circle at one distinct point. And then with that being said, it simply means to say angle B3 is equals to angle D. So that is going to be tan-chord theorem. Anger,
Yeah.
tan-chord. And then now since knowing hore, angle B3 is equals to angle D, which is the tan-chord theorem, we can now continue because that's why I said that there's no need of me drawing another diagram. Reason being is because of the reason why I've said this is actually angle B3 is equals to angle D. Remember, I said the tangent is a line that touches the circle at one distinct point. So you can also
Yeah.
conclude and say, with that being said, you'll say
B1.
B1. You must put a cap on top to represent that is an angle.
Angle B1 is equal to angle E.
Angle B1 is equals to angle what?
E.
Angle E. What's going to be the reason?
Tan-chord theorem.
Tan-chord theorem. So don't forget, the reason why we say tan-chord theorem is because of that theorem says the angle between a tangent and a chord is close to the angle in the alternate segment. That is the tan-chord theorem, right? So that's basically how it works. Angir,
Yeah.
any question?
No.
Yeah. So it's very important that you must know these theorems. Exterior angle of a slightly chord is close to the opposite interior, and then that is theorem 5. Then theorem 6, the opposite interior angles of a slightly chord, they're supplementary. Then you go to this one. So one thing that you need to understand, the tan-chord theorem, or the ones that has a tangent D2. So that is theorem 7, which is this one, the angle between a tangent and a chord is close to the angle in the alternate segment. That is the tan-chord theorem. So we can thus conclude and say B3 is close to angle D, tan-chord theorem, or B1 is close to angle E, tan-chord theorem. And then apart from that one, we also have another one that says two tangents drawn from the same point outside the circle. What happens? They're equal in length. Ne? Are you still with me?
Yes, sir.
Yes. So this is
You
theorem
said that
8.
you're cutting.
Eh?
Wakata. I think it's my network.
Yeah, I think it's a network. So this is another theorem, which is theorem 8. Actually, yeah, it's like this. So remember that here, they will say that is angle B, A, and then here that is B, then here that is C. So this theorem says that two tangents drawn from the same point outside the circle, they're equal in length. So basically, how you're gonna construct this is what you're gonna do. Don't forget that this is it's O. O is always representing the center. And then as you are going to construct this, you're gonna draw dotted lines running through that, as well as this, as well as that. And then remember, here we are having a 90-degree angle. Even here, we're having a 90-degree angle. That is the tangent perpendicular to the radius. Angry, here you're gonna say, as you're writing it properly, so you wanna do this, Angry. You're gonna say OCB, angle OCB is equals to 90 degrees, Angry. So the reason it will be tangent or radius perpendicular to the tangent. We'll say radius perpendicular to the tangent. The reason why we say radius perpendicular to the tangent is because of when you speak about the radius, is any line from the center of the circle to the circumference of the circle. So the reason why we say OC is 90 degrees is because OC represents the radius. So that's why we say radius perpendicular to the tangent, because line BC represents our tangent. Then another thing that you'll basically do, you'll say OAB, angle OAB, it's equals to also 90 degrees. What's going to be the reason?
Radius perpendicular to tangent.
Yeah. So you'll say radius perpendicular to the tangent. So that is this, it's theorem 8. Don't forget. So that is theorem 8. Two tangents drawn from the same point outside the circle, they equal in length. And then from here, that's when you can now conclude. Therefore, the length of BC is going to be equals to the length of AB. Sorry about that. So from here, you're going to conclude AB is equals to BC. Therefore, AB is equals to BC. Reason, remember that in geometry, each and every statement should be accompanied by the reason. So you'll say tangent
Yeah.
perpendicular. No, tangent from the same point. Tangent from same point. Tangent from the same point. Just like that. So that is actually theorem number 8. And then it didn't actually. With regards to
Yeah.
theorem number 2, there are three diagrams that you must remember. So the first diagram is the famous one. Is this one. This one, there's no one else. There's no one who doesn't know this theorem. It's very famous, this one. So that is how the diagram looks. So that is going to be A, B, C, and then here we're going to have center O. So this one, K angle at the center is 2 times angle at the circumference. When you draw the construction should move like that. But in simple case, this will conclude and say, therefore, angle BOC, which is the angle at the center, is equals to 2 times angle A. So that is how the first theorem it is. And then with regards to the second one, we'll get it like this. So all these three diagrams, they represent theorem number 2. You must never forget that. And then this one, your construction, it will run like this. Remember that here, okay, let me do like this. Remember that here, that is center O. That is going to be VOC. Then that is going to be A. So with regards to this one, construction, you will draw dotted lines that moves like this. And then remember, hit the angle at the center. And get this theorem, every angle at the center is 2 times angle at the circumference. Even this one.
Yeah.
At the center is 2 times angle at the circumference. Still, same as applies on diagram number 2, angle BOC, which is the angle at the center, should be 2 times angle A. And then lastly, you're gonna get this one being like this. Even this one, this is angle B here, OCA. So it's still angle at the center, which is this one, is 2 times angle A. So you must remember that angle BOC equals to 2 times angle A. So all of this, they represent what we call theorem number 2. So theorem number 2, what it says, the angle at the center is 2 times the angle at the circumference. So one thing that you need to basically know and do is that for you to master Euclidean geometry, you must know all the theorems. So from theorem 1, the line drawn from the center of the circle to the midpoint of chord is perpendicular to the chord. Remember, we have theorem 1 as well as theorem 1 converse. And then theorem 1 converse, the line drawn from the center of the circle perpendicular to the chord, it bisects the chord. So with regards to what you are seeing now on the screen, that is theorem 2. Theorem 2, you must understand that we are having 3 diagrams that best represents theorem 2. What does theorem 2 says? Theorem 2 says the angle at the center is 2 times angle at the circumference. So should you get theorem 2 that says that the angle at the center is 2 times angle at the circumference, having diagram number 1, that's how you're gonna prove it, and then that's how your construction will go with regards to the red dotted lines. On the middle diagram is still the theorem that says angle at the center is 2 times angle at the circumference. That's how basically you're gonna construct. So those red dotted lines, that's how basically you construct. And then on the diagram, the construction will actually move like this. You'll also have construction because there's no way you can prove theorem 2 without construction. So your construction, those dotted lines, they will actually move like that with regards to the dead diagram. Any question?
No, sir.
You best understand.
Yes.
Okay, can we proceed?
Yeah.
Okay, cool. So that is theorem number 2. It's just that agadi thoma kaolatellana, but I'm just you now know Hagir theorem 1, Hutoma theorem 1, theorem 2, and then let me just try to show you. And then this one, I think it's theorem number 3. Uh, ish, what did I do now? Hey, can't say. I nearly deleted everything here. So yeah. This one, it doesn't have construction. Get theorem number 3. Theorem 3, if the diameter of the circle is subtended angle at the circumference, then the angle subtended is a right angle. Angle in a semicircle. It's a 90-degree angle. If the diameter of the circle is subtended an angle at the circumference, then the angle subtended is a right angle. It means to say if this is A, B, C, here we're gonna have 90 degrees, and then this basically means to say angle B is gonna be equals to 90 degrees. What's gonna be the reason?
Angle subtended from the center.
Angle in a semicircle. Angle
The semicircle.
in a semicircle. Why one angle?
Yeah.
Yeah. And then this one, it doesn't have construction. And then we also have theorem number 4. So theorem number 4, bow tie. So this one, you must remember bow tie. If you can remember bow tie, then this will be easy to you. Bow tie is like that. It's like that. So angles subtended by the same accord that equal get this one. So this is A, B, C, D. So this basically means to say angle A is equals to angle B always. And then let me write it here. Angle A equals to angle B. So that is angles in the same segment, or angles subtended by the same arc chord. Angles in same angles in the same segment. So you write angles in the same segment. Or you can just say angles subtended by the same arc chord. As well, it's very important also because this also, angle C is also equals to angle D. Angle C is also equals to angle D. So same reason. Angles in same segment. Any question?
No, sir.
Yeah. So that is what you need to know. And then Kishia. So that's a theorem one. So theorem one as well as theorem one converses like this. So here you'll be given a chord, as well as this one you'll be given a chord. And then remember that this will be center O here, as well as this one will be center O right there. And then this will be A, M, B, as well as this one A, M, B. Also have a 90-degree angle. Also have a straight line like this. So the only difference for this one will be given, or this is equals to this. Then this one will be given or M1, M2, 90 degrees. So with regards to you being given like this, in an exam, they will just say, prove this theorem. So if this is, let's say, diagram number one, and then let's say this is diagram number two. So this basically means to say on diagram number one, get the theorem that says the line drawn from the center of the circle to the midpoint of a chord, that line is perpendicular to the chord. So if mobile get M1, get M2, and then we are given or AM is equals to MB, or we are given, okay, let's rather write it. We are given or AM is equals to MB. It means to say your RTP, you're required to prove. RTP in maths, it simply means required to prove that angle M1 is equals to M2 is equals to 90 degrees. Or you're required to prove RTP will be you proving that OM is perpendicular to AB, depending on the textbook that basically one uses. Ne?
Yeah.
And then with regards to the second diagram, basically what's going to happen, or here, get the theorem that says the line drawn from the center of the circle uh, perpendicular to the chord, it bisects the chord. So here actually you're actually given you're given that M1 is equals to M2 is equals to 90 degrees. And then this basically means to say your RTP. RTP, don't forget in maths, it means required to prove, right? you must prove for a OM. OM is perpendicular to AB. Or must basically prove that wait a minute. Kirille vice versa mo, because they're given they can't be the same. So here everything is correct. It's just that here this way I need to fix. Yeah. Kidiswapile are the other way around. So this basically means to say this is given. Yeah, and then this will be your RTP. Because it wouldn't make sense if I'm like they've given me for M took 90 degrees, then I want to prove it working 90 degrees. Or taking just a second. Let me be slowly. Yeah, this is given. Because Barbudis or M took 90 degrees. Then this is your RTP. But your RTP here, it should be AM equals to MB. Yes. RTP.AM. Yeah, it's equals to MB. So that's what basically you need to do. Any question?
No, sir.
Yeah, it's correct like this. So in maths, they will just say, prove this theorem. They might not actually tell you in maths to say prove theorem 1 or prove theorem 2 or actually prove theorem 3. So what basically they will do, they will just basically say prove this theorem. So them telling you to prove this theorem, you need to prove the theorem as it is. So it's very important. That was theorem 1. This is theorem 4, angles in the same segment. And then that is theorem 3. Don't forget this one. That is theorem number 3. If the diameter of the second subtend an angle at the circumference, then the angle subtended is a right angle. And then we have 3 beautiful diagrams that base represent what we call theorem number 2, angle at the center is 2 times angle at the circumference. Then up here we are having what we call theorem 8, 2 tangents drawn from the same point outside the circle they are equal in length. And then right here, don't forget that this basically represents Horiki theorem number 7. Theorem number 7. So when you speak about theorem number 7, remember kid, the angle between a tangent and a chord is equal to the angle in the alternate segment, tan-chord theorem. So basically, these are all the notes that one needs to know with regards to you getting a maths distinction. Am I loud and clear?
Yes.
Yeah. So that's how basically it works. So yeah. I think it's wise. Nice just that when I teach, I normally like starting with the basics. But I'm just gonna send questions so that we deal with them. And then if you maybe find a challenge, you can more than welcome to drop me a text. The thing, Ori, I don't want to give a question where but look at I'm not sure Ori, where are you standing. One to So that's why basically I normally give you the important things because I know Ori, me not doing examples, giving you this, I know in an exam you'll be late because maybe some of your teachers the things they get covering, they don't teach them in class. So even if I might not have done examples, but giving you this information, but we are gonna do examples